Usually, Qiangyao Laboratory will provide a peptide testing report to each customer who orders peptides. In today's video, we will talk about how to understand the charts in the peptide detection report of Qiangyao Biotechnology. The purity of peptides is usually determined by reverse phase, high-performance liquid chromatograph, which refers to the percentage of the target peptide peak area to the total peak area at a wavelength of around 220 nanometers. It is an important factor that affects the experimental results. The peptide detection report provided by Qiangyao Biotechnology includes basic information about peptides, HPLC reports, and ESIMS reports. The HPLC report lists the relevant operating parameters of high-performance liquid chromatography at the top, including runtime, wavelength, injection volume, column model, mobile phase, and mobile phase elution gradient. The maximum absorption wavelength of peptide bonds is 220 nanometers. Usually, when the sample is eluted from the column, a UV detector is used to detect it and convert the detection signal into a curve, called a chromatogram, which consists of UV absorbance and sample elution time. The peaks shown in the chromatogram are listed by retention time, meaning that each chromatographic peak represents a substance. The purity of peptides is quantitatively calculated using the area normalization method. Calculate based on the percentage of peak area in the chromatogram. As shown in the figure, the values corresponding to retention time, area percentage, and peak area are presented. The retention time of the target peptide in the figure is 7.608 minutes, and its corresponding peak area percentage is 96.56%, indicating that the purity of the peptide is 96.56%. Next, we introduce the key information of mass spectrometry reports. Mass spectrometry detection is based on the mass-to-charge ratio and is an important means of detecting the molecular weight of compounds. The top is the relevant operating parameters of the electric spray ion mass spectrometry, including capillary voltage, cone voltage, runtime, etc. ESIMS peptide segments into states with multiple charges, recording the mass-to-charge ratio rather than the peptide mass itself. The molecular weight of peptides in positive and negative charge modes is calculated using the following formulas. Among them, the mass-to-charge ratio corresponds to the peak value in the figure. M is the molecular weight of the peptide sample. N is the number of charges carried. In the actual judgment process, slight errors are allowed, and due to the presence of ions with multiple charges, it is necessary to determine ions with more than one valence peak to confirm the molecular weight of the substance. As shown in the figure, it is known that the theoretical molecular weight of the polypeptide is 2,581.99. If N is equal to 5, the mass-to-charge ratio is calculated using the formula in the positive charge mode above, resulting in a peak value of 517.40. The difference from the peak value of 517.28 is very small, which basically conforms to the characteristics of the 5-valent ion peak corresponding to the peptide. Similarly, we can calculate the peak values of the hexavalent peak, tetravalent peak, trivalent peak, and divalent peak to be 431.33, 646.50, 861.66, and 1292.00. We can still find the corresponding ion peaks in the mass spectrum. From this, we can conclude that the SEMS spectrum of the peptide is correct. That's all for the chart display of the peptide detection report. If you have any questions, you can leave a message below the video. Let's schedule another meeting at Qiangyao Laboratory in the next issue.